In this section of the CompTIA SecurityX Certification course, we will delve into implementing security measures in the early stages of the system's lifecycle. Here, we'll focus on the importance of incorporating security at the outset to build a robust foundation. We'll discuss the integration of security practices in continuous integration and continuous deployment, CICD pipelines, ensuring that security is a continuous part of the development process rather than an afterthought. This involves adhering to secure coding practices and incorporating rigorous testing methodologies to identify and mitigate vulnerabilities as early as possible. By embedding these security measures from the beginning, we're able to reduce potential risks and create more resilient systems. Understanding the importance and relevance of implementing security measures in the early stages of the system's lifecycle is crucial for securing any development project. This aspect is not just a best practice, but a foundational requirement for achieving a robust security posture. From a certification perspective, this focus is indispensable. It's essential for securing systems throughout their lifecycle, ensuring that vulnerabilities are minimized early on and systems remain resilient from development through to deployment. By integrating security measures early, we can reduce potential threats, thus building more secure and reliable systems. This early integration of security practices doesn't just fortify your systems. It sets a solid groundwork that aligns with industry standards and certifications, enhancing your professional credibility and capability in creating secure environments. Now we'll delve into continuous integration and continuous deployment, commonly referred to as CICD. First, let's define these terms. Continuous integration, CI, involves regularly integrating code changes into the main branch of a code repository. This practice allows teams to detect and address bugs early in the development process, thereby maintaining code quality and reducing integration issues. On the other hand, continuous deployment, CD, takes this a step further by continuously delivering the integrated code into production environments. This ensures that new features and fixes reach users more quickly, facilitating shorter and more reliable release cycles. Together, CI/CD improves collaboration among development teams, accelerates release cycles, and aids in early bug detection. This approach is essential in developing robust, secure systems and reducing vulnerabilities throughout the system's lifecycle.
To put CI/CD into practical application, we'll need to utilize various CI/CD tools and implement specific commands to manage our workflows. Some of the most popular tools for CI/CD include Jenkins and GitLab CI/CD. These platforms help automate the entire development process, from code integration to testing and deployment. For instance, in Jenkins, you can trigger a build for a job using the Jenkins-CLI build myjob command. This allows you to initiate the build process right from the command line, making it easier to integrate into your development pipeline. In GitLab CI/CD, you can define your CI/CD pipeline in a .gitlab.yml file using YAML syntax. Here is a basic example. YAML stages: build, test, deploy. This example specifies 3 stages: build, test, and deploy. Each stage will encompass its respective jobs, allowing you to systematically progress through each phase of your CI/CD process. By integrating these tools and commands, you're able to seamlessly incorporate CI/CD into your development workflow, which fosters early bug detection and accelerates your release cycles. To ensure code quality and maintainability in your CI/CD pipeline, it's crucial to adhere to coding standards and use linting tools. Consistent coding practices enhance readability across your team's codebase, making it easier to maintain and extend the software. This practice helps to establish a common coding style and removes discrepancies that can lead to misunderstandings and errors. Linting involves static code analysis to identify potential errors and enforce coding standards. For instance, ESLint is a popular linting tool for JavaScript that ensures your code adheres to defined coding standards and catches syntax errors early on. By integrating tools like ESLint into your workflow, you can automatically detect and resolve issues before they make their way into production, ensuring higher quality code and a more efficient development process. Now that we've covered the theory behind linting, let's look at a practical example using ESLint. To set up ESLint in your JavaScript project, you'll first need to install it. You can do this by running the command npm install eslint-save dev. This command adds eslint as a development dependency to your project, ensuring that it's only used in your development environment. After installing eslint, the next step is to initialize it. You can do this by executing npx eslint-init. This command will guide you through a series of prompts to configure eslint according to your project's needs, including setting up coding standards and rules. The benefits of integrating eslint into your workflow are substantial. By identifying potential syntax errors early in the development process, eslint not only saves you debugging time, but also enforces code consistency across your team. This consistency enhances both the readability and maintainability of your codebase, making collaboration easier and more efficient. In summary, setting up and using eslint helps in catching errors early and maintaining a consistent code style, which in turn improves the overall quality of your project.
Branch protection is a critical mechanism for maintaining the integrity of your codebase. By restricting direct commits to main branches, you can enforce a more controlled and review-based workflow, thus enhancing the overall quality of your projects. One effective technique for branch protection is implementing pull request reviews. This ensures that any changes are scrutinized by other team members before they are integrated into the main branch. Additionally, you can set merge restrictions that outline specific conditions which must be met before a merge can occur. A widely used tool for facilitating branch protection is GitHub Branch Protection Rules. These rules enable you to define and enforce policies, such as requiring pull request reviews before merging, thus adding a layer of oversight and quality assurance to your development process. Following these practices helps prevent accidental changes and ensures that only thoroughly reviewed and approved code makes it to your main branches, maintaining consistency and reliability in your code base.
Let's dive into the practical application of branch protection on GitHub. First, to set up branch protection, you'll need to go to your repository settings. Navigate to the Branches section and click on Add Rule. Here, you can establish rules such as require pull request reviews to ensure that any changes to the main branch undergo a review process before being merged. This setup comes with significant benefits. It prevents accidental changes to important branches, upholding the integrity of your main codebase. Additionally, it ensures code quality through mandatory reviews, facilitating a collaborative environment where peers can catch potential issues early on. This way, you maintain stringent control over the changes that make it to your main branches. Continuous improvement is an essential concept in software development, focusing on iterative enhancements. This means continually improving the software through proactive bug fixing and regular updates for new features. In practice, there are a few key techniques to achieve continuous improvement. Regular code reviews play a significant role, helping catch issues early and improving the overall code quality. Feedback loops from users and stakeholders are also crucial, providing insights and suggestions that guide further enhancements. The benefits of this approach are significant. Firstly, it leads to adaptable and scalable software that can evolve with changing requirements. Secondly, it enhances the security posture by ensuring that any vulnerabilities are promptly identified and addressed. On this slide, we will explore Canary testing, a crucial part of your testing activities. Canary testing involves deploying code changes to a small subset of users before a full-scale rollout. The primary purpose of this testing technique is to enable the early detection of issues. By monitoring this small group, you can quickly identify any problems and roll back the changes if needed, minimizing the impact on your user base. A practical example of Canary testing is in Kubernetes deployments, where a new version of an application is initially released to a small percentage of users. This method ensures that any unforeseen issues are caught early and allows for a swift rollback to maintain stability. The end goal of Canary testing is to catch potential issues early and mitigate risks, ensuring a smoother and more reliable user experience when the code is deployed more broadly. Now, let's explore regression testing. This involves retesting previous bugs to ensure they haven't recurred. It's a crucial part of the testing process because it helps maintain software stability and prevents the reappearance of old bugs. By addressing these issues, you can ensure a more reliable and consistent user experience. To facilitate regression testing, tools like Selenium and Junit are commonly used. These tools help automate the process, making it more efficient and thorough. Integration testing is a critical phase of the testing process, where we focus on verifying combined parts of an application to ensure they work together as intended. This form of testing checks the interactions between different modules within the software. One of the main benefits of integration testing is its ability to identify issues at the interfaces of the combined modules. By doing so, it ensures the reliability of subsystems before they move further along the testing pipeline. Essentially, this testing phase helps confirm that different pieces of the system are seamlessly working together. For tools, we often rely on Junit if you're working within a Java environment, and PyTest if you are dealing with Python applications. These tools help streamline and manage the integration tests efficiently.
Automated test and retest is the process of automating the execution of test cases and regularly rerunning test suites. This approach carries significant benefits, such as consistent test environments, meaning that tests are executed in the same controlled conditions every time. This leads to more reliable and repeatable test results. Additionally, automated testing provides speedy feedback loops, allowing developers to quickly identify and address issues. One common tool for facilitating test automation is Jenkins. Jenkins can schedule and execute tests automatically, integrating smoothly with various testing frameworks and providing continuous integration and delivery capabilities. This setup ultimately enhances the efficiency and effectiveness of your testing process.
In this section, we are focusing on unit testing under our testing activities theme. Unit testing involves testing individual components in isolation. This approach allows us to pinpoint specific failures within our codebase, making it simpler to debug and fix issues at an early stage. By isolating each component, we ensure that each part functions correctly on its own before integrating it into the larger system. One of the major benefits of unit testing is that it simplifies debugging. When a test fails, you immediately know which specific component is at fault, which speeds up the development and maintenance process. For tools, if you're working with Java, Junit is a widely used framework that facilitates this type of testing. For Python, PyTest is an excellent tool that is both flexible and easy to use, making it a popular choice among developers. Unit testing is a cornerstone of building reliable software, ensuring small pieces are tested, functional, and reliable before they are woven into the greater whole. In conclusion, we've discussed the importance of incorporating security measures in the early stages of the software development lifecycle. We've highlighted key techniques for enhancing security through continuous integration, continuous deployment, CICD, effective coding practices, and comprehensive testing strategies. It's crucial to understand that by embedding these practices early on, we can develop robust and secure systems. The next steps involve diving deeper into advanced testing tools and committing to continuous learning to stay updated on CI/CD best practices. By following these guidelines, we can ensure our systems remain resilient and secure against vulnerabilities.
Here are some valuable references to help solidify your understanding of the concepts we've covered. Firstly, for continuous integration and continuous deployment, CI/CD, Jenkins is a cornerstone tool, and you can find detailed documentation at the Jenkins website. Additionally, when it comes to ensuring your code quality, ESLint provides robust linting capabilities for JavaScript, and you can get started with their user guide readily available online. For managing your code repositories securely, GitHub branch protection is a critical feature. The GitHub documentation will guide you through configuring branches and merges in your repository to maintain code integrity. If you're looking to dive deeper into continuous integration practices, I highly recommend the book Continuous Integration: Improving Software Quality and Reducing Risk by Paul M. Duvall, which provides comprehensive insights into enhancing your CI workflows. These resources will be instrumental as you implement and refine security measures and best practices in your software development lifecycle. Thank you for your attention throughout this course. If you enjoyed the content, please leave a like. If you have any thoughts or questions, comment below. Make sure to subscribe to the channel so you don't miss any future updates. And don't forget to share this course with friends and colleagues who might find it helpful. Your engagement helps us improve and continue providing valuable content. Thank you.